Well, good morning or good afternoon. It's good morning for me. It's not quite noon yet. I'm Jay Harris. I live in Las Vegas, Nevada. Have a web consulting firm, Arana Software. You can tweet me at Jay Harris on Twitter. Feel free. I encourage you to use the hashtag database confidence to help with the conversation now or throughout the talk or in the future, especially if you have any comments or questions, because inevitably the best question that you come up with is going to be the one after the session is over. So feel free to hit me up there. I'll set up. So I'm a coder. I'm an entrepreneur. I've been recognized as a Microsoft MVP, as a Microsoft Regional Director. I've been a web developer for over 20 years now. Speaker forever, a business owner. And in my time in professional IT, whether that's working for corporate America or through my own consulting or even my time as an independent developer, I've learned that possibly our most common source of anxiety in our applications, in our source code, in our technology stack is our lack of database confidence, our lack of confidence that we have in our databases, in our ability to touch it, and our ability to interact with it. It seems brittle. We're scared of it. So let's talk about that. This talk is anxiety-free databases for .NET Core. This is a talk for the next hour. It's going to be exclusively about relational databases. It's going to be about .NET Core and C#, though these concepts and tools may apply to the full .NET framework. We're not going to be discussing the full framework within the next hour. The focus here is also going to be partial towards the heavy ORMs like Entity Framework Core and NHIBERNATE. What we're not going to be going over is this is not going to be about SQL. We're not going to be talking about the SQL language or about database security, about SQL injection, about attack vectors. This will also have no applicability towards NoSQL or any non-relational database engines. And specific samples will not include any of the light ORMs like Dapper or Petapoco or anything that's direct ADO calls. The concepts that from this talk might apply to areas outside of this scope, but we're going to keep this pretty tightly focused over the next hour. So why are we scared? Why are we worried about our database? We have these massive databases that have been around for, in some cases, decades, literally decades. Working with a client right now that the database was created in the early 90s, and it's still powering the web application right now. But we have elements of our code base that have been around just as long. And it seems that even though we have some fear against that older code, we don't have anywhere near as much anxiety about that code, that old code, as we do about the old database. So, and it also isn't the technology stack. Even if we don't have as much familiarity with SQL or advanced SQL topics, or even building stored procedures and indexes and views and user-defined functions, we still have that anxiety. Even just simple CRUD databases, just select, insert, update, delete, brings us just as much anxiety as those complex stored procedures do. So instead of focusing on what we don't want, perhaps focusing on what we do want. Let's focus on what gives us confidence. Perhaps let's look at the confidence that we already have from our application code and our application tools and try and replicate that. Well, what can we get? What gives us confidence in our application code? Certainly tests, unit tests, integration tests, any type of tests. Tests in our application code absolutely give us confidence in that portion of our technology. But most projects have zero tests involving the database. In fact, we've been told there's thought leaders in our industry that'll often say, don't test the database at all. And in some cases, I agree with that. I agree with not testing core database functionality, but in the same sense, I agree with not testing core application code functionality. It's not about testing, let's say, Redmond's code, Microsoft's code on the .NET framework so much as it's our C# code that's built on top of that. So this isn't about testing the SQL Server engine itself as much as our code that we've written on top of that. We don't need to write a unit test to make sure that 2 + 2 = 4 inside of .NET. But we certainly would write tests to make sure that we're adding the right numbers or calling the right arguments into our addition function. And maybe the same thing would apply to testing our databases. Automation is another area that gives us confidence. We can click a button to build the entire application code base. We can click a button to make a release. We can click a button to deploy the code. Many of the complex tasks around our application code base have been turned into a bash script or a DOS script or a PowerShell script. But have we done the same thing for the database? Not so much. Often, even production deployments use just a schema comparison tool to diff the test database from the production database and just oftentimes blindly applying those schema modifications from test or staging into production. There's very little automation in handling many of our database code bases. Repetition. We get a lot of confidence from from the repeatability of our code base. A lot of that even comes from source control. For the current revision in Git, for the current commit inside of Git, if we compile that revision right now, or compile this same revision a month from now, it's the same result. And because of that, if I run the unit tests against this revision now, or run the unit tests against this revision a month from now, it's the same result. And because of that, if I deploy this revision now, or if I deploy this revision a month from now, a year from now, it's the same result. Our code base has this repetition built in. It's consistent because of our change tracking. It's consistent because of our tests. It's consistent because of our automation. But our database, we don't have that. There's no repetition of our tests, of our deployments, of our validation. That schema diff that we're just using for our schema diff tool for deploying tests to production, it might be different tomorrow. It might be different next week. There's challenges to even a simple guarantee of the script that we run today is going to be the same script that we can run next week, let alone a month from now or a year from now. And that's not even just impacting redeployments of the code base, but even just the initial deployment of the code base. If we're using a diff tool to diff test versus prod, it might have a different output depending on just if we're making the production deployments today or Monday morning. And of course, recovery. When things go bad, how do we roll back? From our code base, we can just reinstall the latest release. We'll probably have it in a zip file or on a build server, and we just redeploy that code. But what about our databases? Do we have any migration scripts that, aside from migrating it forward, migration scripts that can roll the database back? Have they been tested? Have they been automated? Have they been proven through repetition? You know the phrase, if you don't test your restore, do you really have a backup? We don't have these recovery processes on our databases. In many cases, a recovery from a failed deployment is just a full restore of the backup we made immediately before we started the deployment. If we remembered to make a backup immediately before we started the deployment. And even if we do restore that, any changes in between that backup time and now are lost. So we know exactly what gives us confidence in our application code base. And those same principles apply to our database code base. It's just more code after all. We just don't do it. We should, but we don't. But we should. So how? How do we make that happen? Well, first we need to make it testable. We have to build testability into the system. We have to have functionality in place that can be reliable under test. Where failures are an issue with a primary code base and not just a failure with the test structure or with the random data that we decided to query against inside of the database. We have to build testability into our code base, our database code base. It has to be verifiable. Once we have a code base that can be tested, now we have to make the actual tests, but in a sensible way. And it has to be repeatable. We need reliable results. We need to be able to run that unit test against the current revision today or tomorrow or next week or next year and always get the exact same results, because only through that repeatability, only through it having the same result every time, do we actually begin to have any sort of database confidence. So how do we begin? Well, we can start with schema validation. And through a lot of these tools and ideas for the rest of the hour, these are going to be all open source tools that are available for right now for our for testing and validating our database code base. So we can begin with schema validation. And schema validation really is a step one, because it's making sure that our system has the same expectation with itself. That's not even so much of making sure that the system meets our expectations. It's just that it meets its own expectations. So making sure that the models and the classes that we've built in C# in our application code match what is being presented in the database. Those models and classes might be wrong, but at least make sure that the database matches those models and classes, that the system meets its own expectations of itself. So two options that I'm going to go over for schema validation. One is going to be based on NHIBERNATE. One is going to be built on Entity Framework Core. So the two most popular for the heavier ORMs. And there still is a lot of NHIBERNATE usage, particularly in the older full framework stuff that's slowly making its way, migrating into the .NET Core world. So to start with, NHIBERNATE. Now this is going to be using functionality that's been around forever, for easily a decade. It was initially built, I think it came out with NHIBERNATE version 2.0. We're currently NHIBERNATE is currently on version 5.3.2. And that's going to be through the schema validator class. This is NHIBERNATE's schema comparison. This is where the tool begins. And more specifically, it starts with the schema validator's validate method. And now this is not model validation. This has nothing to do with making sure that the password string field has at least 12 characters in it and that it's using an uppercase and a lowercase and a number and a symbol, or making sure that the age field is at least 18 or at least 21. This is a schema validation of making sure whatever model that you've presented inside of C# matches the model that's being presented by the database table. This is testing the data definition layer. So to make this work, inside of a new schema validation test, we just new up the schema validator class, passing in our session configuration. If you're not familiar with NHIBERNATE, session configuration it's similar to DB context in Entity Framework. And once we have this class, it's just validator.validate. We run this, the console output is just going to throw an exception if it doesn't match. And it will let you know inside of the exceptions details what the problem was. Perhaps we have a organization class, and inside of our organization class, the model in C#, it has a string name property. But when we've executed this schema validation, the table organization was found, but it didn't have a column named name. So schema validation would have failed. We can certainly wrap this in a test. Like many of the generic unit tests that we've all written, just wrap this in a try-catch, because what we really want is the validation errors that are coming out of the exception and put them all in a nice, pretty format that we can understand quickly without having to dig through an exception stack. So for each validation error that's come on the exception class, just write those to the output, whatever the needs meet for your unit testing framework, and then rethrow it so that the system knows, nope, this really broke. We need to mark this as a failed test. As far as converting this over into Entity Framework Core, that one can just come off of context.validate schema. So again, it was very similar to the session configuration. In NHIBERNATE, we can build this off of the Entity Framework context directly. So this is just going to be context.validate schema. Now, this is used in current Entity Framework Core. Entity Framework Core, this would work with anything EF Core 2.1 or beyond. It's currently on 3.17, but this is not part of the out-of-the-box stuff coming from Microsoft. There is no built-in schema comparison functionality off of Entity Framework. Now, we got tired of there not being one, so we built one. Open source Entity Framework Core validation library is available on NuGet. It's currently 1.3.2 to support EF Core 3. That brings us in that context.validate schema just as an extension method, and it'll do the same thing as the NHIBERNATE stuff would. Execute it, and it will let you know if there's any missing columns on any missing tables or any missing tables to begin with. So once we have our schema validation in place, part of that testing and their repeatability is also making some choices around the engine that we're going to use to test our databases with. Of course, this can be full SQL Server. This can be the EF Core in-memory tool. This can be SQLite's in-memory tool, as well as SQL Server LOCALDB. Now, many would say, why not just use the same as production? Okay, well, so let's start there. SQL Server, full-on SQL Server. We can use standalone SQL Server just like we use in production. And it's tempting because we probably already have some edition of SQL Server that's installed locally on our development machine, or at least some sort of shared developer SQL Server instances of our database that our localhost instance can utilize, a centralized dev server or a centralized test server. I don't know. However, I recommend against this. This is very heavy-handed, and this is also going to be subject to collisions. If multiple developers or even multiple concurrent tests have to use the same table or record. Let's say, for example, in our suite of tests that are integrating against SQL Server, one is going to be pulling down a sea of records, and one of them is going to be deleting all of the records in the database. Could be, depending on how those are going to be executed, either from you and me both executing our unit tests at the same time, or even both of those unit tests, those integration tests on my local machine executing, but with some sort of parallelization. Wow, that's a tough one. In place to make those tests make us run through the suite faster. They could step on each other. If they run at the same time, they might step on each other. So I recommend against using full-on SQL Server. Now, of course, we could also use something like containerization. Maybe put SQL Server inside of, I don't know, Docker or some sort of a container that would help. That would help eliminate some of the collisions, right? Because I could just spin up my own database instance inside of a Docker container and go with that. Then two people executing the unit test at the same time. Sure, that would eliminate that collision, but we're still subject to the collisions from multiple concurrent tests running on my machine at the same time. If those two unit tests execute at the same time on my machine, still just one database, they're still going to step on each other. Not to mention Docker is going to be, or any container system is going to be very heavy-handed. It's going to be very slow when we're talking about the speed that we demand of our unit tests. We want to be able to press a button, to make those unit tests go, and they're finished in seconds, not, okay, I'm gonna go get some more coffee. We don't want to sit there and wait very long while our unit tests, because that's the context switch. Even if it's our own brains, we hate context switch from our application code. We know how expensive a context switch is going to be for our computers, so we also want to avoid it in our own minds. It's like, you know, the boss knocking on our cube wall or on our door and interrupting us when and that technical speech bubble over our head is gone. So we want to make those unit tests run as quickly as possible, and containers are going to slow a lot of that down too. So still recommending against that. What about EF core in memory? Well, it's designed for unit tests. It's incredibly fast, and each test can get its own instance of the database. Each test can get its own instance of the database. So that would eliminate any of the collisions. There's not going to be any collisions even on your local unit tests running in parallel, to say nothing of other developers running at the same time as yours, because each test is getting its own instance. However, EF core memory is essentially a giant property bag. It's not even a real relational database. So it's going to take whatever you tell it and write it down. It might not even be real. It's not going to have any actual schema validation on it. It's not going to have any foreign keys. It's not going to have any primary keys. It's just a giant property bag. We can't, this will work for well, being a property bag for holding our data. It's not going to work for anything where we want to do some schema validation in it, just because it doesn't have that relational database structure to actually verify the relational database, the schema. So still a no-go. SQL Server LocalDB. SQL Server's LocalDB creates an instance of your database in the bin directory. So it's certainly isolated from other developers, reducing some of those collisions. And it's light. It's incredibly fast. It's very fast. But SQL Server LocalDB also has its own issues because it's not cross-platform. And under the default configurations, it's still just one database for your test assembly. So all of those unit tests that are in the single assembly could potentially collide with each other. We could still have those collisions in our database integration tests. And finally, SQLite in memory. This one's cross-platform, great for the .NET Core stuff. We can run it on a Mac, we can run it on Linux, we can run it on Windows. Even if all of your developers are running on Windows, oftentimes I've seen in .NET Core that we're getting to where our build servers might be running on Linux because they're cheaper, they're faster, they're not as heavy as a full Windows system. But it has its own issues too, even though it works. It has low referential integrity. Foreign keys are not so much of a thing here in SQLite. And that'll be fine for many areas of validating your database code and database integrations, but it isn't enough for a full schema comparison. So, which brings us back to SQL Server LocalDB. It's not cross-platform, but we need something with full referential integrity so that we can get all of those foreign keys built in. So we can make this work with some modifications. We can use a randomized connection inside of our test fixtures, inside of our test setup. And so we can randomize an associated file name that's going to be inside of our bin to initialize it so that every test will get its own copy of the database. This will work. Only drawback here is that it's going to be Windows only. So with our engines, I'd recommend those last two, using either SQLite in memory or SQL Server LocalDB. SQLite in memory doesn't give us the full referential integrity, doesn't give us the foreign keys, but it does give us cross-platform. SQL Server eliminates the cross-platform, but does give us the keys. So it's a trade-off between the two. You can also set it up so that it would run in both. And for both the NHIBERNATE schema validation and the Entity Framework Core schema validation, it doesn't care which database you use, and it understands the capabilities of each different database engine to use the appropriate test. So that schema validation will give us validating the names, it'll validate the types, it'll validate most of the keys. Certainly always validate the primary keys, and it'll validate the foreign keys if we're on LocalDB. It'll validate our indexes, it'll validate our views. Again, that does not necessarily mean that the system meets our expectations, but we can at least make sure that the system is in agreement with itself. It meets its own expectations of itself. So schema validation passes. What next can we do to help with that database confidence? Well, certainly migrations is going to help a lot of it. It brings us repeatability. It gives us the automation for our deployments, for our migrations still, for Entity Framework Core, and for, well, Entity Framework Core or anything else. We'll start with the EF Core way that's coming out of the box with Microsoft. So Entity Framework Core, certainly recommend at least an EF Core 2 for any of this stuff, even though we're still on 3.17 for what's released right now. Most people may be familiar with the add migration command coming in out of the PowerShell console inside of Visual Studio. I'm not really a fan of it. I don't so much like the add migration method at all. That's a lot of cruft. Adds a lot of nonsense to this migration system, most notably that it builds a local model so that the next time it can just diff the local model instead of going and diffing the database. This is really for a code first kind of platform. But I found that a lot of shops, they're not code first. They're a little bit of database first and a little bit of code first, particularly if there's multiple applications that are all trying to work against the same database. So sometimes the modifications are made in the code first, sometimes the modifications are made in the database first, and I find that add migration doesn't really support that. Again, it builds a local model, and the next time you run add migration, it just diffs the local model against what you have in your C# code, your application mode. And if you've made changes directly to the database, lots of times that's going to be missed. So I think we can do better. I think we can do better by just building the migration classes, the EF Core migration classes ourselves. They're not that complicated. They're pretty easy to build. So here's a sample of one of those migration methods that are inside of the class. This is protected override void up. So this is migrating up, deploying new code. This is not the rollback, which would be down. This is up. So everything begins with protected override void up, passing in a migration builder instance. It's very similar to the context builder that we have for building out our models on our database context. Inside of protected override void up, we're going to have our builder is going to then be able to create our table, passing in whatever name we want to give that table. Takes in a columns property where we pass in this, it takes in an argument, a table argument for this method where we can begin building all of our individual columns off of this, such as our ID column is just going to be a column that we create as a GUID or whatever type that we want to give it, an int or whatever. And also accepts in different arguments for this column method, this table.column method, for things like the length of the column or its nullability or what its default value should be. Down below, we also have, in addition to the columns argument, we have a constraints argument where we can add all of our primary keys and foreign keys and so on, passing in their appropriate names and what of the columns above are associated with that constraint. So I find these pretty straightforward, and this is going to be a very similar migration convention to what are used in other libraries as well. In addition to the protected override void up, we have a protected override void down. This is our automated rollback to put the database back the way that it was before the deployment instead of having to completely restore everything from a backup. In this case, the up created the organization table, so the down just needs to drop it. There are other methods available. So instead of just creating and dropping tables, we can add columns, we can alter columns, Or if we need to drop down just to straight SQL, we can do that as well with builder.sql and execute some sort of SQL statement. Both of these methods, the protected override void up and protected override void down, are going to be wrapped inside a migration class. Whatever we want to call that migration class, it's going to derive from Entity Framework Core's migration class, and it's going to have two arguments associated with it. One is the type of the DB context. With the Entity Framework Core's migrations, we can store, if your application is connecting to multiple databases, we can have one assembly that has all of our migrations in it, and each migration is just flagged for the database context that that migration is associated with. And we give that migration a name through the migration attribute, passing in some sort of string for its name. Especially when we're building our own, I recommend basically using, it's a datetime toString. That keeps them all unique, keeps them all in order, and helps guarantee that if I'm working on let's say I'm working on a Git branch, if I'm working on a feature branch that builds out some new thing and has some migrations, and you're on your own feature branch building out your new thing, when we get them all merged into our main Git branch, those names won't collide. They can still work with each other. So the migration for this one is, if I created it on May 29th at 3:20 p.m., so migration name would just be 2020-05-29 at 15:20. Now, if you're not using Entity Framework Core, or even if you are and you want to use something different, there are other options available to you. My other favorite is a library called Fluent Migrator. This is functionality that's been available with Fluent Migrator since version 2.0. It's currently on 3.2.8. The migration classes are very similar to what we have with the Entity Framework migration. So public overrides that are protected. This one's public override up. From there, we have methods that are a part of the class, such as create. Create has some extension methods on it for creating a table, passing in the name of whatever the table was. From there, further methods of with column, passing in the name of the column and what its type was, as GUID, as int16, as Boolean, and all of the other properties that we need, such as its nullability. And here, unlike Entity Framework Core, where we had a separate section for its constraints, with Fluent Migrator, all of the constraints are directly associated with creation of the column. So here, this one is our primary key. So there's a method off of this specific column that says, hey, this is our primary key, and passing whatever name we want to give that PK. Overall, still a relatively easy structure to parse, and has a lot of similarities with Entity Framework Core. Down is similar still, public override void down, where instead of drop table, it's delete table. There's methods off of the schema, so we can check to make sure that it exists before we try and delete it. I do like this language better. I'm a fan of the delete.table syntax more than I am of EF Core's drop table syntax. To me, the whole point of having these C# based migrations is to abstract away the developer's knowledge of SQL. If they were inherently familiar with SQL, if they were a DBA, then they're probably just going to write straight SQL commands. If we're going to get into these migrations, there's not as much of a requirement that the developer, maybe they're a junior developer, I don't know, and they're not as familiar with SQL commands. They know that they're going to want to delete the table. They might not necessarily know the specific SQL syntax for delete and know that it's called a drop instead of a delete inside of SQL syntax. So I like the more generic terms, such as delete table in the Fluent Migrator syntax. Still additional commands that are available to us in Fluent Migrator, altering a table to add a column or to alter a column. Unlike Entity Framework, it's all just one line, multiple commands acting on a single table, whereas EF Core migrations, it's a separate alter and a separate add, the separate statements entirely. and still can drop down to SQL if we need to. Very similar to Entity Framework Core's migrations, or perhaps Entity Framework Core's migrations are similar to Fluent Migrator's syntax. All of this is wrapped inside of a migration class that derives from Fluent Migrator's migration base class instead of Entity Framework Core's base migration class. Still has an attribute of migration. We don't have a DB context, so there's no DB context attribute. That does mean that every database needs to have its own migration, let's say its own migration assembly. But we will still give it a name. This one is a numeric identifier instead of a string identifier, but still use that same 2020-05-29 at 3:20 in the afternoon. However, here we can also give it a, let's say, a human consumable name, add migration table. And that human consumable name will appear in all of the appropriate logs, rather than just you having to magically remember that the 3:20 p.m. migration was the one that went and created the organization table. We can have some human consumable output. So our migrations, keep in mind that with our migrations, we're going to have statements, we're going to have functionality for creating our tables and all of that data definition around our tables, all of the foreign keys, all of the indexes, all of the columns, the column types, the properties on those columns, or dropping down into raw SQL. We're not going to have functionality about for views, for functions, for stored procedures. For those, if we want to create those, we are going to have to drop down into raw SQL to create those. Why do I want to go through all this? Why can't I just execute an SQL statement against my production database when it's deployment time? Well, easy. This is automation. This is repeatability. This is recovery. And most importantly, this is validation. With this migration code, we can wrap unit tests around this so that we can have this migration thoroughly tested through unit tests, through integration tests long before it's deployment time, so that we already know that they work long before it's time to execute against these production. So let's get into that, validating our migrations. So here we'll start off with Fluent Migrator, with validating those migrations. This is functionality that came along in Fluent Migrator with 3.0. Unlike the base migrations before, that syntax was in 2.0. This is since 3.0, we're on 3.2.8 right now. We need to do a little bit of setup inside of our unit test to make sure that we can execute these unit tests. This is all for setting up the service collection, the dependency engine, the dependency injection engine around our unit tests. Very similar to setting up that service collection in a new ASP.NET Core instance inside of our startup class. So we'll begin by instantiating a new service collection and setting up all of the base Fluent Migrator core functionality inside of that service collection. Excuse me. Then we're going to configure our runner. Our runner tells it what sort of engine that we want to run this against. In this case, we're going to run this against an SQLite engine. And we also want to specify where our migrations are. I don't want my migration code inside of my website's deployed assembly. For me, I like having those in separate assemblies, and certainly with the different connection strings. They're not going to run off of the same connection strings, because my migration code is going to be running alters, it's going to be running creates, it's going to be running drop commands in SQL Server. It's going to have a much higher level access into my database to be able to modify this definition layer. I don't want my normal application execution running under that high of a privilege. I don't want it to be able to drop the user table just for fun because someone took advantage of a SQL injection issue that they found. We specify the assembly that's going to have all of this so that my application code can never execute the migration code. And then once we're done, similar to the setting up the builder in ASP.NET Core, we'll set up the builder, we'll build the service provider, for running our migrations. Now, it still won't quite work. This will create a connection, run the migrations, and close the connections. This is fine if we're just going to manually execute the migrations, but we don't want that. We want a little bit more than that. With SQLite in memory, the database goes away when we close the connection. That's just how SQLite in memory works. And we want to reuse that existing connection so that that existing database we can run our validation against that existing database. Since this base stuff, since out of the box, Fluent Migrator is going to open the connection, run the migrations, and close the connections. Once it closes the connections, it's gone. We can't then do schema validation on it to make sure that, hey, the stuff that we just built, the new database that we just built with all of the latest migrations in it, making sure that that still matches our C# models and classes. So we do have to do a little bit of override to make this functionality work with that idea. We have to make the connection ourselves and keep it alive when we're done. So a little bit of extra work. We're going to start with a test processor class so that we can do that. We're going to build out this test processor. It's going to derive from the same database engine that we were connecting to when we set up the service collection. So in this case, the SQLite processor. Inside, we're going to give it a constructor, a special constructor that's also going to take in the database connection. And then we're going to override Fluent Migrator's base processors that automatically ensure the connection is closed. When it's done, we're going to override that class to a do nothing, to a no op. So it's still going to execute this ensure connection is closed method, but that's going to do nothing. So of course, the connection is not really going to be closed. It's going to be still, it will remain open so that our unit tests can run some validation against it. So this is going to be our test processor class that overrides it. Some additional setup inside of our service provider. We're going to pass in a DB connection into this dependency injection setup. We're going to pass in our test processor and let it know that whenever we want an migration processor, which is the underlying class for this, make sure that we give it the test processor and give it the name that we gave that processor. We called it test processor in the last screen. So this will allow us to fully test our Fluent Migrator stuff inside of unit tests. Again, just like Entity Framework migrations, Fluent Migrator migrations weren't really designed to be run in this manner. They were both just designed to go run some migrations. So they both do this, but we want to override a little bit of that functionality so that we can put this into unit testing. Unfortunately, there's so much focus on don't test your database that we don't have great tools for testing our database when we actually could and get some database confidence. So now for testing these migrations, we'll begin with this for new databases. So inside of our unit test, we have our fact that it should run the migrations. We have our runner that we set up. So we go call that service provider that built service collection, and we want the migration runner instance out of it, and run runner.migrate up as opposed to migrate down. We want to migrate up to run all of those latest things. And then when we're done, we'll just run some sort of assertion to make sure that the table exists, the organization table exists, or whatever sort of validation that we want to run to make sure that our migration is executed properly. If we want to make this roll back as well, certainly, if you don't test your recovery, do you actually have a recovery process? So we can also make unit tests that roll back those migrations. So in addition to all of the other functionality that we had of getting a migrator and migrating up, we want to pull it all to the latest changes because that's what we would in a production deployment. We'd deploy everything, and then if something broke, then we'd go back. So replicate that in a unit test to migrate up and then put it back to the version that it was. We can add this with rollback to version. If we want to go all the way, version 0 should be an empty database since we're talking about a new database here. And we would flip that assertion to make sure that the table does not exist. Because if we'd rolled back to an empty database and the organization table is still there, then something's wrong with the migration that we wrote. And we can further wrap this inside of our validate schema. So that context.validate schema, this is still using our Fluent Migrator migrations. We'll add in that validate schema method from before, and we can still catch, just like we did in our earlier unit test, we can catch all of those validation errors. So we don't just need to manually test, hey, does the organization table exist now that we finished our migration? We can just do a full schema comparison between our finished migrated database and whatever our C# models were. So with this, not only do we have a full migration process in place through Fluent Migrator, we have a way to make sure that that post-migration database matches everything inside of our C# models. If we wanted to do that with Entity Framework Core, for this one, it's context.database.migrate. And that will use all of the base functionality, assuming that the migrations are in memory, or all in the appropriate loaded up assemblies. This will run all of the Entity Framework Core migrations that we have and still run that same context.validate schema. To do this inside of NHIBERNATE, functionality is still available since NHIBERNATE 2, even though we're on 5.3.2. In here, we still have, under the Fluent Migrator syntax, our service provider.getRequiredService. The concern is going to be around the schema validator, session configuration.validate. Like with before, we need to work around making sure that we pass in the database context. The schema validator out of NHIBERNATE is going to open a new connection, run the validation, and destroy the connection. And we can't do that. We need to pass around this in-memory connection. So we have to maintain that. So schema validator.validate won't work because it doesn't pass in a new connection. It wants to create a new one. We can get around that with a few lines of code with our SQL dialect, so that we tell the validator engine which type of database we're already going to use, and set up database metadata for that database connection. And then outside of that, run session configuration.validate schema instead of the schema validator.validate. And finally, the final option for any of our database stuff is in data validation, because oftentimes we're still going to want to validate our data. An example might be if we have some sort of interceptor or hook around our database calls, because every time we save changes to the organization table, maybe we have audit columns on the table. We want to know when was the last time this record was changed, or what user account was the last one to change it. And that's just through a hook that's overriding the save calls. So we might want to still make sure that that correct information was written. For Fluent and Hibernate, there's some great tools around that have been around since version 1.3. Fluent and Hibernate is on 2.1.2 right now. Fluent and Hibernate is a Fluent configuration and testing syntax that sits on top of and Hibernate. So with this, we can check individual properties. It should map organization properties. So we would create one of the Fluent and Hibernate persistence specifications against our organization object. By passing in the session, it's already gotten all of the appropriate configurations in place. So it knows what the column names should be. It knows what the table names should be. So on that specification, we're just going to check the property for organization.name, give it a string value, organization.the description, give it a string value, is approved, give it a Boolean value. We could put randomizers on there if we wanted to. What this functionality will do is initialize, instantiate a new organization object, set all of these properties, save it to the database, completely clear the ORM's cache. So we're not running off of a local in-memory version of the organization object, completely clear the cache, reload the database object or the organization object from the database, and validate that the properties are still exactly what they are. We can do this allows us to do things like matching the organization column or the auditing columns, all the way through making sure that we didn't truncate a value, because maybe we're not properly saving the sign on a numeric property, or we're truncating the organization name to 50 characters. So we can check a lot of that data integration stuff as well. Using NHIBERNATE, we have a few other options as well. As an example, so with this, we can just wrap everything inside of a transaction. Again, we're using in-memory databases, whether that's LOCALDB or whether that's SQLite in memory. So we want to keep that same connection open. So we just put everything inside of a transaction for its testing. So very simple database stuff of, in this case, we're going to create a new department. A new department, of course, requires that it be a part of an organization. So we're going to create a new organization with that as well. Name the organization, name the department, save and commit it, because we might want to delete the department. And of course, we want to make sure that our cascade configuration, still our code, we know that delete cascades work just fine, but we know that we might not have turned on cascade deletes properly in our configuration. So we're testing our configuration, not SQL Server's implementation of cascades. We can actually go delete that department, and when we're done, make sure the department is gone, but make sure that the organization is still exists, because deleting the department shouldn't take the organization with it. So cases where we're still testing out our consumption and our configuration of databases. So this gets us through our tests. This gets us the ability to write schema tests. This gets us the ability to write data tests. This gets us through our automation, not only in creating these migrations that we can easily run repeatable deployments of our database, deployments that'll run the same way today as they will tomorrow, as they all run next year with that repetition, but it also makes sure that they'll run the same way. They'll run the same way every time. And we can recover from them if something goes wrong. We have actual testable, tested, and repeatable rollback functionality as well, because inevitably, every once in a while, those production deployments are going to go bad, and we need to revert what we had and not just go through the trauma of restoring a production database backup while our bosses and managers and other people and users are breathing down our necks saying, hey, when can you get this system back online? And we're offline for hours waiting for a database to restore, because that's the only way we can roll back. And through all of this stuff, through these tests, through the automation, through the recovery, through the repetition, that gives us some level of database confidence. It brings to us all of the same stuff that we have in our application code base to get confidence in that, and applies those same principles to our database code. It's all just code. It can work all around. So, if you have any questions, feel free to hit me up on Twitter at jharris. Again, I encourage you to use that database confidence hashtag. And j@aranasoft.com if you have any further questions beyond this. I think we got a few more minutes for some questions if you have some, but if not, certainly thank you for coming. Thank you very much.